8.5. The first law of thermodynamics. The first law of thermodynamics tells us that the internal energy of a system can be increased by adding energy to the system and doing work on the system. Mathematically, we can write down the expression for the first law of thermodynamics as delta E is equal to Q plus with W. Bear in mind that all of the signs here are positive because delta E is the positive change or increase in the internal energy. Q is the energy or heat added to the system. And then W is also positive because we are doing a positive work on the system. There are many processes through which this could be accomplished, which we will take a look later in 8.5, thermal processes, and then it is valid as long as energy is conserved. The energy conservation law, it relates changes in internal energy to energy transfers due to heat and work. It is applicable to all types of processes and provides a connection between microscopic and macroscopic world. 8.6. Thermal processes. For our reference, this is the equation for the first law of thermodynamics. Delta E is equal to Q plus with W. When we want to increase the internal energy of a system, we can add heat as well as do work on the system. Let's start firstly with isobaric process. In isobaric process, the pressure stays constant. It will create a horizontal line on the PV diagram as shown in this figure. The work done is area under the graph and it can be calculated using this formula. W is equal to negative P delta V, where delta V is the change in the volume. It is equal to V final minus with V initial. Pressure needs to be in Newton per meter square and then the volume must be in meter cube. Moving on now to the second thermal process, which is going to be adiabatic process. The special characteristic for adiabatic process is there will be no heat exchange with the surrounding. In this case, Q is going to be equal to 0. So when this happened, referring back to our first law of thermodynamics, when Q is equal to 0, delta E will now equal to W. It will create a curve in the PV diagram and it will jump from one isotherm to the other. The definition of isotherm, it refers to the curve on a PV diagram joining points representing state of equal or constant temperature. For each of these curves, it will have a specific temperature. The nearer the curve towards the origin, the temperature will be lower. So we can assume, for example, this is going to be imaginarily 20 degrees Celsius, and then this can be higher, for example, 30 degrees Celsius. So when we have adiabatic process, the temperature will change from its initial to the final temperature. The third thermodynamic process is isovolumetric or isochoric. In this case, the volume will stay constant, thus the name isovolumetric, and it will create a vertical line on the PV diagram. So this is going to be the isovolumetric process as shown in a PV diagram. Since there is no area under the graph, the volume does not change, so the work done is going to be equal to 0. Since the work is equal to 0, delta E is equal to Q. The last thermal process that we're going to discuss is going to be isothermal. In this case, the temperature stays the same throughout the process, and the work done on an ideal gas during an isothermal process will be equal to N RT ln VI over VF. N will be the numbers of mole, R will be the Rydberg constant, and T will be the temperature. And we have a natural log or ln Vi over Vf. The special characteristic for isothermal is going to be that delta E is equal to 0. And we can also relate to the first law of thermodynamics. Since delta E is equal to 0, W will be equal to negative Q.